Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Abdul Halim's here and welcome to my channel. In this video, we are going to demonstrate some of the applications of geometric sequence and series. This is our example number 1 application of geometric sequence and series, that is to find the rational number represented by the repeating decimal 2.417. Alright, and we have a bar above 117. Now this number is in the form of a decimal, and we would like to convert it into fraction, okay, if it is a rational number. Okay, the same thing goes if we have a rational number that is in the form of a fraction, we can convert it into a decimal. So now this number that is let us write it down again. We have 2.417 bar. Now what that bar actually means is this, that is 2.417, and that 17 is repeated like this infinitely many times, okay, without ending like that. 2.417171717 like that. Now instead of writing a number like this, mathematician, okay, would like to simplify it, okay, the way we write it. So we write 2.417 bar, and we understand the meaning of it is just we repeat 1717, okay, the number below the bar. So in this case, the number is just 2.4171717 like that. Now the question is, we would like to find, or we would like to convert, okay, this decimal here into fraction. So how to do that? Yeah, this is the time, okay, we can use geometric series. The idea about geometric series to convert this decimal into a fraction. So maybe we can write this decimal here in a different form, that is equal to 2.4 plus 0.017 plus 0.00017 plus 0.0000017 plus, and so on. Okay, follow the same pattern. Infinitely many goes to infinity. All right. Now if we look carefully at this sum that is starting from 0.017, okay, goes to infinity here, this is just a geometric series. This is a geometric series. All right, where, as we mentioned, okay, in the previous video, a geometric series have to have the first term and have to have the common ratio. Okay, now let's write down that geometric series, take it out, okay, find the sum of it, and then we will come back to this original problem. Okay, let's write it down again one more time. Okay, this time we are going to write down just only the geometric series, that is 0.017 plus 0.00017 plus 0.0000017, and follow the same pattern, goes to infinity. Alright, so we have our A is equal to A1, the first term is equal to 0.017. Now what is R? That is the common ratio. Do we have common ratio in this case? Now let's see. For this pair, that is the first two numbers here, and let's see, divide, okay, this term divide by this term and see whether we have, yeah, let's see what we get. 0.00017, we are going to divide it by 0.017. Okay, in this case we are going to get 0.01. And let's see, let's do another one, okay, and see what we get this time. Okay, we are going to use this pair. Okay, the next pair, that is, we are going to divide 0.0000017 divided by 0.00017 and see whether we get the same R equal to 0.000 0.0017 divided by 0.00017. Now this ratio also we have 0.01. Okay, therefore in this case seems like we have the common ratio, right? That is 0.01. We have A1 0.017. Now I hope you still remember, because this is an infinite series, you know, and this is a geometric infinite series, and we have a very special formula for it, that is as infinity. As infinity, I hope you still remember this formula, that is equal to, for infinite geometric series, we have this formula, that is A1 over 1 minus R. Okay, with the condition that the absolute value of R must be less than 1. Or another way, we can say that the value of R must be between -1 and 1, must be greater than -1 and must be less than 1. Now in this case, our R is 0.1, I mean 0.01. Yes, it is this number, that is our R here, in this interval. Alright, it is between -1 and 1. Therefore, okay, our series here, that is this series, okay, we can find the infinite sum of it by using this formula. Alright, because all the condition is satisfied. So now let us use this formula to find S infinity. Okay, so S infinity equal to A1 we have 0.017 divided by 1 minus R, 1 minus 0.01. Okay, let's simplify this. 0.017 divided by 0.99. Okay, let's simplify so that we have a proper fraction. We have 17 over 990. Yes, we already have, okay, the infinite sum of that geometric series. That is, okay, the sum of all these numbers, okay, starting from 0.017 goes to infinity. The sum of it is equal to 17 over 990. Okay, therefore the original problem, okay, let's write down the original problem. Let's go back to our original problem. The original problem is this, that is 2.1417 bar. This is equal to, we write down just now, equal to 2.4 plus that geometric series, right? This geometric series here, this geometric series, and that sum is equal to 17 over 990. So we are going to replace that geometric series by 17 over 990. 17 over 990. Now let's simplify this sum, and let's see what we get. This is equal to, in terms of fraction, this is equal to 24 over 10 plus 17 over 919. Okay, now let's take common denominator, that is 990 equal to 990. Now let's multiply 24 divided by 99. We have 2376 plus 17, and that will be equal to 2393 over 990. Okay, right, now let's write it down. Our conclusion for this problem, that is 2.417 bar is actually equal to 2393 over 990. Okay, they have the same value, but we write it in the form. Okay, on the left we are writing it in the form of decimal, right, and on the right hand side we write it in terms of fraction. Okay, now let us continue with second example. Now in this problem we have an employee's starting salary is 26,750 ringgit per year. He received a 1.6% annual raise. Find his total earnings at the end of 5 years. So we want to find the sum. okay, of his earning during that 5 years. So maybe we have to list down all the earnings according to year. So for the first year, his total earning is 26,000. Maybe we have to write down first year. 26,750. How about second year? How much he get? Okay, during second year. Okay, his raise is 1.6%, so 26,750 plus 1.6% multiplied by 26,750. We add these two numbers together, this one and this. Okay, we will get the what we call the earning in second year. Now let's do that. What is this amount? So we have to multiply 1.6 multiplied by, that is 1.6 over 100 multiplied by 26,750. That's equal to, we have 428. So his earning during the second year is equal to the sum of this number with this number. Okay, that is 26,750 plus 428. That is altogether the total is 27,178. Yeah, that will be the earning at the end of the second year. Now, how about the earning at the end of the third year? The third year will be 27,178, okay, plus 1.6% of this amount, that is 27,178. Okay, we have to calculate this amount first and then add it to this number. Then we will get the earning at the end of the third year. I leave it to you as an exercise to find how much the earning, okay, at the end of the third year. Now let's list the amount of earning in the first year, that is 26,750. Since we are going to to find the total earning at the end of the fifth year, so we have to add, okay, the earning during the first year, the second year, and so on. 26,750. Okay, this number is the earning, okay, during the first year, at the end of the first year. How about the second year? We have 27,178 and plus so on. All right. So our A1, that is the first term in this case, is 26,750. Now, our common ratio R is equal to 27,178 divided by the first earning during the first year, that is 26,750. If we divide that, we'll have 1.016. Okay, that will be the common ratio. Now we need to find, the problem is asking us to find what is S5, that is the total earning at the end of the fifth year. Okay, now we need to use this formula, that is Sn equal to A1 in bracket R to the power n minus 1 over R minus 1. Okay, as long as R is not equal to 1. Okay, in this case we have R equal to 1.016, is not equal to 1, so it is valid, okay, to use this formula here. So to find S5, we just substitute all the values that we have. So to find S5 equal to A1, we have 26,750. Our R is 1.016 raised to n, that is n equal to 5 minus 1, then close bracket. Okay, we have to divide all these by R, that is 1.016 minus 1. Now if we do the calculation correctly, we are going to get this amount, that is 138,099.032. Okay, that's the total amount of, okay, of his earning at the end of the 5th year. Okay, since this is the amount of money, so maybe we have to write down the answer in the form of a sentence. So the total earning at the end of the 5th year is, okay, so we have to write down in terms of RM. So total amount is RM 138,099 ringgit 0.032. This is example number 3. A rubber ball is dropped from a height of 60 meters. If it rebounds approximately 2/3 the distance after each fall, approximate the total distance the ball travels. So maybe before we start with our calculation, maybe it's better for us to sketch a diagram to represent the situation. Okay, there is a ball, it drops, and this is the ground here. Suppose this is the ground, and the ball drop or falls for 60 meters, right? And then since this is a rubber ball, so it will rebound after it hits the ground, and it will rebounds the distance of 2/3 of the distance that it falls. So it will rebound, suppose up to that distance only, that is 2/3 of 60, that is equal to 40 meters going up, and then from there it will go down again also for 40 meters, right? And then after it hit the ground for the second time, the ball will rebound again going up. This again, this is 2/3 of 40, that is equal to 80 over 3 meters. From that position it will go down again for the same distance, that is 80 over 3 meters. After it hit the ground, it will go up again, okay, for the distance of 2/3 of that distance, that is 2/3 of 80 over 3, that is equal to 160 over 9, and it will go down again for the same distance, that is 160 over 9, and the process continue forever, right? So the problem is asking us to find the total distance the ball travels, that is going down and then going up, going down and then going up again, going down again, up and down, okay, forever, without stop. The process continue forever, right? So maybe we can break down the total distance travel to two parts, two components, that is the distance travel downwards and the distance travel upwards. So we write down total distance travel equal to the sum, that is the sum of the distance travel upwards plus the distance travel downwards. So we find each one of these, that is the distance travel upwards, we find the distance travel downwards, and then we add them up together to find the total distance. Okay, maybe we can find the distance travel downward first, right? See here, downward 60 meters, right? The first one 60 meters, and then this one also going downwards, that is 40 meters. Another one here, okay, going downwards also 80 over 3 meters. There is one more here. The distance travel downwards 160 over 9, and the process continue. There is more distance there, and we are not going to write it down. It's going to infinity. Alright, so we are going to list the distance travel downwards first. So we have, let's write it down, distance travel downwards. Okay, equal to, we start with 60, right? Here, see here, downward 60, and then 40. So we have 60 plus, then we have 40, that is this distance here, 40. Then we have this distance, that is 80 over 3. 80 over 3. Write one more. That this one 160 over 9. 160 over 9, and the distance continue forever. Okay, so I hope you notice that this is infinite geometric series. All right, so what we call the value that we are looking for is actually S infinity. Remember the formula for S infinity? That is A1 over 1 minus R. Okay, R in this case is 2/3. That is because R equal to 2/3, that is 40 over 60 is 2 over 3, right? And A1 is equal to 60. Now let's substitute to find the value for S infinity. S infinity is equal to A1 is 60 over 1 minus R, that is 1 over 2/3, equal to 60 divided by 1/3. This is equal to 60 times 3, that is 100, 180 meters. This is the total distance travel downwards. Next, we are going to calculate the distance travel upwards. Okay, distance travel upwards. Equal to what? Now let's list the distance one by one. Okay, let's see our figure again. We have down this now upwards, right? Yeah, we are looking for upwards, right? Yes, we are looking for distance travel upwards. First 40, and then this one is up also. This 80 over 3, 40, 80 over 3. We have 160 over 9, and so on. So we start with 40. All right. So we have 40 plus, we have 80 over 3 plus 160 over 9, and so on and so forth, goes to infinity also. So we notice that this is an infinite geometric series. So we can use that formula again as infinity. As infinity equal to, the first term is 40, and the second, the common ratio, the common ratio is 2/3 also, so 1 minus 2/3. So this is equal to 40 over 1 over 3 is equal to 40 times 3, that is 100, 120 meters. So we already find the distance travel downwards 180, and the distance travel upwards is 120. So now we can find the total distance. The total distance travel is equal to the sum of the distance travel upwards, that is 180, plus the distance travel, this one is downwards, upwards is 120, so the total will be 300. The total is 300 meters. Example number 4 says this: suppose that a town records its first 2 COVID-19 cases on day 1. If the number of persons infected with COVID-19 triple each day, how many persons will be infected after 1 week? So maybe we need to list the number of persons infected by COVID-19 day by day. On the first day, in this town, only 2 persons infected by COVID-19 person, and it's triple each day. So the next day will be triple of 2 will be 2 times 3, that is 6. Okay, each day it will triple, that is from 6 becomes 6 times 3 is 18. Now triple again, 18 times 3 is 54, and so on and so forth. Okay, continue the same pattern. Alright, now clearly this is a geometric series. If we look carefully, we know that A1 is equal to 2 and R, that is the common ratio, is equal to 3, right? Now we would like to find how many persons will be infected after 1 week, that is 7 days, right? So we are looking for A7. But before that, maybe we need to write down the formula for AN. Hope you still remember the formula for AN in geometric sequence. AN equal to, we have A1 R to the power n minus 1. So let's substitute the value of A1, R, and n. So we are looking for A7, right? A7 equal to, A1 is equal to 2, R equal to 3, and we have n minus 1, that is 7 minus 1. This is equal to 2 times 3 to the power 6. Right? This is equal to 1458. 1458. So after 1 week, the number of persons infected by COVID-19 in that town is 1,458 persons. This will be our last example in showing the application of geometric sequence and series. The example says this: one day you saw an interesting video on Master Halim YouTube channel. At 1 p.m. you shared the video to 4 unique people. Then at 2 p.m. each of your friends shared to 4 unique people. Then at 3 p.m. each of their friends shared it with 4 unique people. If this pattern kept on happening, then how many unique people received this video by 10 p.m.? So in order for us to answer this question, maybe we need to write down the terms of the sequence and then we add them up together, because we want to know how many unique people received this video, what is the total number of people received this video. So the first term is 4. Okay, starting with 4, and then these 4 persons, each one of them shared with 4 unique people. So this is for at 1 p.m. Now at 2 p.m. the number of people received the video becomes 16. Now at 3 p.m. these 16 people, each one of them shared to 4 unique people. Okay, each one of them shared to 4 unique people. So at 3 p.m. the number of people received the video is 64 persons. And then the same process at 3 p.m. each one of these 64 people, they share, each one of them share to 4 unique people. So it's become 64 times 4 is 256 plus. Okay, the process continue. Okay, the question is, you want to know what is the total number of people receive this video by 10 p.m. by 10 p.m. Okay, we want to add these numbers up to A10 like this. All right, now if we look carefully at this series, we see that the value of A1 is equal to 4, right? And the value of R is equal to 16 divided by 4 is equal to 4. A1 4 and R also 4. And we would like to know, as S10. Okay, this is the formula. Sn equal to A1. Remember this formula, r to the power n minus 1, okay, over r minus 1. We are going to apply this formula. We have A1 equal to 4, and we have r equal to 4, and we are looking for n when n equal to 10, right? This also we have. We can substitute it into this formula. So we are looking for S10. S10 equal to A1 is 4, then we have R also, sorry, R also equal to 4, so 4 to the power 10, right? And then we subtract 1 over R is 4 minus 1. Now if we do calculation correctly, we are going to get this number, that is 1,398,100. Yeah, this is the number of people receive. Okay, the number of people receive that video by 10 p.m.